Hello, this is Mr. Kors. It's a hot day here in the building. This is the video for Friday, August 28th for Advanced Inorganic Chemistry. What I'm going to be doing is reviewing the first semester with you today. I haven't sent it yet, but I will send a sheet that says Inorganic Chem First Semester Chemistry Review Class Problems. And I'm going to be going through these problems on the board. Of course, you can pause the video if you'd like to try to do them by yourself before I do the answer. And I'm going to talk through them. And it's going to be a long video, so I'm going to start with the first problem. All right. So the first problem I have here is convert 8.2 meters to inches. Excuse me, I'm going to close the door. Somebody's talking really loud out in the hallway. You know, and while I'm at it, I'll get my calculator. See, just like what we'd be doing in class. All right, so convert 8.2 meters to inches. All right, so what I'm going to do is I'm going to give you, yes, a test on this the end of the following week. All right, and it's going to be a review of what we did for the first semester. And I'm not talking to the camera. I don't know where I'm supposed to be. All right, let's try this. Okay, so anyhow, it's going to be a review of the concepts that we learned in the first semester of regular chemistry. And I also have a sheet that you can follow as well. Review for final. I did it. This is the same worksheet that I gave you when you were in regular chemistry. Oh, so I should start there. Chapter 1, scientific method, nothing. All right. Chapter 5, metric system. I have a conversion problem and a density problem. So here's the conversion problem. All right, convert 8.2 meters to inches. All right, so if you remember, and I hope you do, to do these problems, you start off with 8.2 meters over 1. 8.2 meters over 1. I'm hoping that you can see that. All right, I wonder if I can move this closer, if that will help. I did try this out before. I don't know if you can see that. If I say that, that's going to help. So 8.2 meters over 1. All right. I don't know how many inches are in a meter, but I do know how many centimeters are in a meter. All right. So I know that there's 100 centimeters in 1 meter. And the reason I chose centimeters is because 1 inch equals 2.54 centimeters. That's my conversion factor. So I'm going to write 1 meter here, 100 centimeters on the top, meters cancel, and then I'm going to use my conversion factor. 1 inch equals 2.54 centimeters. I gave this to you for, the test that you took and the final that you took in the past. So I would give it to you again as well. All right, I want centimeters to cancel, so I'm going to write down 2.54 centimeters because you know that 2.54 centimeters is the same length as 1 inch. And remember, I wrote that stuff over here. Oh, I guess you can see it if I write over here. I wrote that down over here. 1 inch equals 2.54 centimeters. Hey, so there it is. I might as well write down D equals M over V. That's my next problem. Okay. And then, remember, this was the tough part of setting it up. The easy part is punching it in your calculator. So I shall do that right now. All right, so 8.2 times 100, or as we say in Milwaukee, 100. And then that's going to be divided by 2.54. And the answer is 322.83 inches. 322.83 inches. Okay, I'm going to pause here. The next thing that I have written down is Chapter 2, Matter, Physical Change, Chemical Change, Physical Property, Chemical Property. And I'm going to write this on the board rather than just say it. All right? So, in a physical change, okay, remember I said about a physical change can be changed back. All right? That's not true in every case, but you can think of it. It can be changed back. And Classic example is ice melting. Right now, I'm melting. All right, then chemical change. That can't be changed back. All right, and then the classic example that I've given you in the past is metal rusting. Okay, and then I wrote down physical property, chemical property. Let's say a physical property has to do with the substance itself. And then chemical property. Oh, can't see me. Can you see this? Let me check if you can see that. Oh yeah, this is great. Chemical property, let's say, has to do with how the substance interacts with another substance. Oh, brother, I don't know if you can read that. Okay, so chemical property has to do with how the substance interacts with another substance. Backwards talking, and my physical property has to do with the substance itself. An example of a physical property could be its color, density. Oh, I forgot I was going to talk about density. Well, I'll do that next. Sorry about that. All right, and then chemical property, an example of that would be, I don't know, chemical property, metal rusts when exposed to oxygen. Okay, I wrote down O2 for oxygen, remember that? Okay. All right, I had forgotten to go through a density problem. Oh, I'm sorry about that. Okay, and the problem I have there for number 2 is a liquid has a density of 1.25 grams per ml. You know what? I'm going to pause it, and then you can see if you want to do the problem yourself before I do it. Okay, I wrote down over here, I wrote down D equals 1.25 G slash ml, V for volume, volume! Equals 60 milliliter. What's the mass? All right, so I'm going to write down, so you guys and girls remember this, I'm going to write down D equals M over V. For density equals mass, volume. So remember what I did in the past, and I'm going to continue to do in the future, is write down 4 equals 8 divided by 2. All right, D corresponds to the 4. M corresponds to the 8, V corresponds to the 2. Alrighty then. Okay, so what I'm looking for is M, the mass. I know that 8 is equal to 4 times 2, so M has got to be equal to D times V. That's the way that I do this. So I'm going to write down M equals D times V, where the density is 1.25 grams per ml, and the volume is 60 milliliters. All right, then I will punch that out on my calculator. I know I could punch these out ahead of time, but what fun is that? All right, 1.25 times 60. I got 75. I made up this problem. I got a round number. This is crazy. Okay, so 75 grams is the answer. I forgot to mention what's the attendance assignment for today, so I'm just going to say what is written on my shirt. And look, I've moved by the periodic table. So that's the question. I got to set that up. I got to remember to set that up. So that's going to be your attendance question for Friday. What does it say on the top of my shirt? Okay. Anyway, All right, the next thing that I have written down here is, what do I have written? Oh, geez, I got those papers over there. Excuse me. All right, the next thing I have written down says, I'll stay off camera for this if you can hear me. It says, Chapter 3, Chemical Foundations, Elements, Atoms, and Ions. Understand what symbols and numbers on the periodic table represent. Be able to identify the number of protons, neutrons, and electrons from the periodic table. State general physical and chemical properties of elements from the periodic table. And identify charges of common ions from the periodic table. Okay, so I'm going to start off with that first example there. And if you want to, I don't know, I'm going to pause it in case you want to see if you can figure this out. Okay, I think you can barely see right there over here on the screen. I have 27, A, L, and 13 written down. So my first question is going to be how many protons? And how many protons do I have there? The number is 13. Where did I get that from? 13, I'll walk over here, is the atomic number of aluminum. All right, the atomic number tells me the number of protons and the number of electrons in a neutral atom. So there's 13 protons and 13 electrons. All right, then I have written down there how many neutrons. All right, so how many neutrons? All right, now 27 is what's called for an isotope the mass number, and I talked about that just once in regular chemistry, and the idea was to get you to learn about this, and if you took physics or are taking physics, you'll learn more about isotopes there. All right, so anyhow, the atomic number for aluminum is 26.98. Now I'm going to assume, I'm not going to send a copy of a periodic table, I'm going to assume that you can find one online, but I do have to send you a copy of something else. So anyway, 26.98, that tells me the average total number of protons and neutrons in a typical atom of that element. I cannot have a fraction of a neutron, so I rounded it up. All right, so if this tells me the total number of protons and neutrons, if I want to figure that out, I take 27 protons and neutrons minus 13 protons gives me 14 neutrons. All right. It's kind of like the question, if I've got 5 pieces of fruit and 3 are apples, how many oranges do I have? Trick question, they were apples and bananas. Gotcha there. All right, now something else I have written down there is metal or non-metal. I don't know if you guys and girls remember this. I'm going to stand in front of the periodic table. All right, I'm sorry I'm making an object of beauty less beautiful. Anyway, do you remember that the metals are found to the left of the zigzag? All right, if you take a look at your copy of the periodic table that I gave you eons ago, you will see that there's a bracket up above that explains that. So all the metals are on the left side and all the non-metals are on the right side. So aluminum is considered to be a metal. So metal or non-metal. Okay, the next one I'm going to talk about is, the next example I have is sulfur, and I talk about the charge of its most common ion. So I'm going to pause here and see if you remember that. I'm going to erase this, and then I'll talk about that. Okay, my next example is sulfur, and I wrote down what is the charge of its most common ion. All right, now I am going to give you that infamous solubility chart to help you with that. You'll see the charge written down there, but I don't know if you remember how to find these charges from the periodic table. Now, I also wrote down for a question its most common ion because in the future, I'll be sharing with you the various oxidation states of different elements, and you're going to find out that it wasn't like I lied to you, but I didn't tell you the complete truth. For example, sulfur, well, it has one common charge, but it also has a pretty bizarre charge as well. All right, so I don't know if you remember this, but all of these have a charge of +1. All of these have a charge of +2. So the first column, most common ion, has a charge of +1. Second column, charge of the most common ion is +2. In the middle, it's pretty much +2. There are some exceptions. I ask you to remember, in particular, silver is +1. All right, now in this column, aluminum is +3. I think I might have said in the past, these are all +3, but I'm really just talking about aluminum, and again, you're going to learn about that in the future. Let's skip this column. N is -3, but I'm not going to ask you that. This column is -2. This column is -1, and these are noble gases. They don't commonly react, so they don't have a charge. All right. My pen almost fell. Okay, so anyway, I will repeat these again. +1, +2, pretty much +2, aluminum +3, skip, -2, -1. Perhaps you remember me saying that in the past. All right, so let's take a look over here. All right, so I wrote down what is the charge of its most common ion. The charge of its most common ion is -2. All right, then I wrote down how many protons in the ion. How many protons? Well, the number of protons don't change because they're located in the nucleus of the atom. It would take an enormous amount of energy to remove them. So you have 16. How many electrons? Now this is the tricky part. All right, you would say 16. But wait a minute, I'm talking about its ion. Its ion has a charge of -2. And if you haven't figured out, if you don't remember, electrons have a negative charge. So this -2 means that it has an extra 2 electrons. So it is 18 electrons. Some kids think 14 because they see that -2. No way. All right, it's going to be 16 with 2 more, 18 electrons. Likewise, if I bring up sodium, Na's got a charge of +1. All right, it's got 11 for its atomic number, so how many protons? It's going to be 11. How many electrons? Since it's got a charge of +1, that means 1 electron is missing, and it's 10. Hey, I was gone for a while, and I came back. Anyway, I'm going to send you a copy of this. All right, you're going to need this to do the next. You're going to need this to do the next part. Or you could use the copy of the periodic table, but you're going to find this to be more helpful. All right, so anyway, the next thing I have there is Chapter 4, Nomenclature, and I have some examples. I don't know if you want to give it a try first. Why don't you do that? And I will return with these written on the board. Well, you can tell by the way it's written on the paper that, I have to buy a program for $200. I think it's $175 if I want to be able to write formulas correctly. Anyway, so I have LiCl. All right. And by the way, in case you're wondering, I'm not going to ask you about any nonmetals, all right? That's something we talked about in the past, but I'm not going to do that. We're going to have plenty of nonmetals in the second semester for this class. Okay, so anyhow, I have Li. Li is lithium. The first name is the name of the positive ion. The second name is going to be the name of the negative ion. It's just going to be chlorine, and you change the ending to IDE. So the name is lithium chloride. All right, the next one, you might say, Mr. Kors, that's easy. That's iron bromide. And you'd be half correct. Do you remember that with iron, you have to tell me whether it's iron 2 or iron 3? And determine that. You cross Chris, you go backwards. That works most of the time. That would have been a charge of +3, so it's iron 3 bromide. Alrighty, this one here, magnesium. And then I've got sulfur. Oh, wait a minute. That's a polyatomic ion. If you take a look at that solubility chart, you'll find the name of SO4, that is sulfate. So the name is magnesium sulfate. I can always tell the kids who didn't pay attention in class who they are because they would have written down magnesium sulfur oxide. All right, for this example, I want you to, give me the formulas. And I think that's more difficult than giving the names. So anyway, I'm trying with this board, and if I turn on the lights, it just gets weird. So you have, like I said, I'm hoping that you can follow along on the sheet and listen to what I'm saying. If you're having problems reading the board. All right, so calcium iodide. See if you remember how you do this. Calcium is Ca with a charge of +2. Iodide is I with a charge of -1. And remember, we crisscross the charges, ignore the signs, just like when you drive, don't write down the 1. So don't write down a 1 here, write down a 2 there. So CaI2. Okay, next one, ammonium. Okay, now ammonium is the only positively charged polyatomic ion that I'm holding you responsible for. NH4 with a charge of +1. Sulfate, SO4 with a charge of -2. Okay, so you crisscross, a 2 goes here, but wait a minute, this is a polyatomic ion. If I have more than one of these, I use parentheses. All right, and I don't write down the 1, so the formula is NH42SO4. Then cobalt phosphate. Cobalt is CO with a charge of +2. Phosphate is PO4 with a charge of -3. And I crisscross there. CO3, PO4 in parentheses 2. 3, 2. Crisscross, that's what I got. There you go. CO3, PO4 in parentheses 2. Okay, next I have equations here. All right, and I have an example of direct combination, single replacement, and double replacement. And those are the examples I have written down on that paper. All righty then, so H commonly has a charge of +1, O has a charge of -2. All right, so I have to combine those two. I don't write down H2, I write down H. All right, remember I would say check your chart, but I don't have hydrogen there. All right, hydrogen, its ionic form has a charge of +1. Then I got oxygen, all right? Same thing, if you take a look at your solubility chart, here I'll pull out my copy so you know what I'm talking about. If you take a look at the solubility chart, you will see that oxygen is O with a charge of -2. So I'm going to write down here O with a charge of -2. All right, so there are 3 steps to doing these problems. Remember, the first step is to predict the products. The second step is to write correct formulas. And the third step is to balance the equation. All right, so I predicted the products. I predict that the product will be hydrogen oxide. Oh my gosh, there it is. It's hydrogen oxide. Amazing. All right, now I have to write correct formulas. I write down a 2. I don't write down the 1. And then the third step is to balance the equation. 2 H's, 2 H's, 2 O's, 1 O. Remember, you don't put a 2 here. You put it in front of the whole thing. All right, so I'm going to need to wipe these out. I'm going to wipe out the charges. If real life were like that. All right, so 2 times 2, I put a 2 there. 2 O's, 2 O's, all good. All right, next example. I've got magnesium, which is a charge of +2. Hydrogen is +1, Cl is -1. All right, so this is a single replacement reaction. I have to have something new on the other side, and it has to be a positive ion combined with a negative ion. So I'm going to put Mg with a charge of +2 together with Cl with a charge of -1. All right, and then H is left over. Okay, so I predicted the products, magnesium, chloride, and hydrogen. Now I have to write correct formulas. I'm going to crisscross 1, 2. All right, and then H, remember, it's one of those that's when it's by itself, it gets a 2 beside it. I don't think you're going to have to keep that straight for the test that I'm going to give you. But just in case you want to know, the ones that form stable diatomic molecules are, we'll say they're diatomic, H2, N2, O2. So, and it's the halogens. I got an F2, Cl2, Br2, and I2. Love chemistry. All right, so it's the ones that form stable diatomic molecules. So when they're by themselves, they get a 2. I believe that's what I've said in the past. H2, N2, O2, F2, Cl2, Br2, and I2. Okay, next I've got a double replacement reaction. Na is plus 1, NO3 is minus 1, Ba is plus 2, and Cl is minus 1. So Na is going to combine with Cl, so I write down Na. Do I write down Cl or Cl2? No, just Cl, because if you check your chart, that's what's written down. That's got a charge of minus 1, plus Ba, and then do I write down NO or NO3? I write down NO3 because that is the formula for the nitrate ion. By the way, Ba is plus 2 and NO3 is minus 1. So I have predicted the products, sodium chloride, barium nitrate. Now, I wipe these out, plus 1 and minus 1 cancel, and then I crisscross 1 and then 2. So 1, 2. All right. You know what? I had to balance that equation. I forgot about that. With my excitement of doing this, I forgot to balance that. Well, I'll come back to that. All right, so I'm going to balance this one. You know what? I'll balance that one because it's easier to balance. Okay, so just, here we go. Back to this one. 1 mg, 1 mg, 1 H, 2 H's. I'll put a 2 there. 2 Cl's, 2 Cl's, all good. Okay, over here, 1 Na, 1 Na, 1 NO3, 2 NO3. So I'll put a 2 here. 2 NAs, I'll put a 2 there. 2 NAs, 2 Cl's, 2 Cl's. So that's what you do. Sorry I forgot to balance this one, but I got distracted by doing that. I think that's my lame excuse for that. All right, on to the next part. Now, if we were having regular 45 or whatever minute classes we have, with you doing the examples in class, we would have paused there. And then the next day we'd move on to here. But since we're doing double classes, here we go, folks. All right, so I have got this here, HCl plus NaOH. Remember the 3 equations? I think it's the part that a lot of people don't like. All right, so I chose a simple one at first. All right, and I don't know if you practiced this already. If you haven't, you want to practice it, pause it now, and then, I'll be back. Now I'm back. All right, so anyway, H is plus 1, Cl is minus 1, Na is plus 1, OH is minus 1. So H is going to go together with OH, and Na is going to go together with Cl. Now I chose an easy one at first, and you'll find out why later. But anyhow, let's see. HOH, that's the correct formula. NaCl is the correct formula. And I believe it's balanced already. Now, but do you remember what you have to do? You have to take a look at this chart and see if it's I or P on your chart. All right, because remember, these 3 things stay together. If it's I on your chart, P on your chart, or if it's HOH. All right, I have HOH. Those 3 things stay together, so HOH is going to stay together. I'll look up NaCl just for fun. Let's see if I can do this. All right, so here is, where is Na? I don't have the light on so much here, I can't see. Oh, there it is. Okay, and then sodium is soluble all across. All right, so if it's soluble, it's going to split apart. I think S for split apart. All right, now everything on the left side splits apart. I have H with the charge of plus 1, Cl with the charge of minus 1, Na with the charge of plus 1, OH with the charge of minus 1. Arrow! HOH stays together, and then I have Na and Cl. Now remember, what you also do in this step is cross out what looks exactly the same, what appears to be exactly the same. So Cl cancels out, Na cancels out, and then I write down what's left behind. H plus OH, arrow HOH. Okay. I'm going to just write the next one down and do it. If you want to pause, go ahead. So I have chosen barium chloride plus, what do I have there? Oh, Na2SO4, sodium sulfate. I know why I chose this. Okay, here we go. All right, I'll write down B and C just to get it over with. Okay, so Ba, I'll write down the charges here. Plus 2, minus 1, plus 1, minus 2. So Ba with the charge of plus 2 combines, write down SO or SO4. Check your chart, it's SO4. So BaSO4 plus 2 minus 2 plus Na. I don't write down Na2, I just write down Na. Na's got a charge of plus 1. Likewise, I just write down Cl, not Cl2. Okay, I predicted the products. Okay, and crisscrossing, that's cool. That's cool as well. All right, so now what do I do? All right, so let's see. Now I get to balance the equation. 1 barium, 2 Cl's, I'll put a 2 here, 2 NA's, 1 SO4, 1 SO4, all good. Now I'm going to check my chart, all right, and I'm going to see that barium sulfate, where the 2 meet, there's an I. So I'm going to put an arrow pointing down, and like I said in the previous example, everything with sodium is soluble. So that's going to split apart. So when I get to step B, this stays together, this splits apart. And remember, everything here gets split apart. So I write down Ba with a charge of plus 2. Do I write down Cl2 or 2Cl? I write down 2Cl. Don't forget the charges here. That's what a lot of students do. 2 Na, not 4SO, but SO4. Why that? Because check your chart. Likewise, it's 2 Na, not Na2, because Na2 is not the formula for sodium ion. Na is the formula. Then I have SO4 with a charge of minus 2. Okay, arrow, BaSO4, I'll put that arrow down next to it, plus 2 Na, plus 2 Cl. Remember that 2 is distributed. I have 2 sodium ions and 2 chloride ions. So there you go. Now, what I have to do is I crisscross what looks exactly the same. The 2 NAs look the same. The 2 Cl's look the same. And so then I write down Ba plus SO4, arrow, BaSO4. I will step aside. Again, I don't know how well you can see this. I'm taking a look and, oh boy. All right, so there you go. All right, my next question is how many moles in 23 grams of barium nitrate? Okay, so what you're going to do, and I wrote this down in the review, you're going to have to remember to use GMA, where A is sometimes grams to moles to atoms, and atoms can sometimes mean molecules. I'll just write down molecules here. And then remember, 1 mole is equal to 6.02 times 10 to the 23rd. All right, so I'm going to go from grams to moles. I'm going to go from grams to moles, so I don't have to worry about the atoms. But what I have to do first is find the molar mass of that. And I chose one that's a pain to solve. I did that on purpose. All right, so you have to look it up on the periodic table. You have to look up the atomic mass. And if you forgot which one is the atomic mass, that's the number with the decimal. Barium is 137.33. I remembered that. Wow. All right. Now I've got 2 N's. So 2 times 14.01 plus I have 6 oxygens, 6 times 16. So I add those all together. I have, let's see, 137.33 plus 2 times 14.01 plus 6 times 16. I have 261.35. And I'm not finished with the problem. I haven't even started. I just found the molar mass. Okay, so I'm going to go from grams to moles. I have 23 grams, there's a surprise. 23 grams over 1, 23 grams of barium nitrate. So I'm going to write down 1 mole barium nitrate. So 23 grams of barium nitrate. Underneath that, I'm going to write down 261.35 grams. All right, because 1 mole of barium nitrate molecules weighs 261.35 grams. And by the way, they're technically not molecules. All right, they have to be nonmetals to be molecules. So I take 23 divided by 261.35 on my calculator. So let's see, 23 divided by 261.35. And I get 0.088004592. Let's call that 0.09. So 0.09 moles. Really? I gotta do that. Yeah, that's right. 0.09 moles. Okay. My next question I have there is how many molecules, and this time I did use the quotes, in 82 grams of CuSO4. So this time I'm going to have to find the molar mass again. CuSO4, copper 63.5. Oh, I have to look this one up. I don't know if it's 5.4 or 5.5. It is 5.5. 63.55 grams plus 32.07 grams for sulfur. I gotta look that one up as well. Yes, because and also 32.06 plus 4 times 16. All right, remember that 4 only goes with the oxygen. I'll punch that out of my calculatory. 63.55 plus 32.07 plus 4 times 16. 159.62. 159.62 grams per mole. Okay, now here we go. All right, so 82 grams over 1. All right, I don't know if you can see this, can't you? I'm going to go from grams to moles to molecules this time. All right, remember you can do that backwards too. So 82 grams, 1 mole, CuSO4, underneath that 159.62 grams. So I went from grams to moles. Now I'm going to go from moles to molecules. 1 mole, CuSO4. Then I'll have 6.02 times 10 to the 23rd molecules there. Moles cancel. So on my calculator, I'm going to go 82 divided by 159.62 and then times 6.02 times 10 to the 23rd molecules. All right, I'm going to assume that you remember how to punch exponents on your calculator. I'm going to have to explain that online to my regular chemistry students. So 82 divided by 159.62 times 6.02 exponent key 23. I get 3.09 times 10 to the 23rd. So 3.09 times 10 to the 23rd molecules. There you go. That should be that. Well, the next question is, what is the mass percent of each element in barium nitrate? And I chose barium nitrate because we did that earlier, and here's the molar mass for it, so we didn't have to calculate it again. But I had to because I erased the board, and I just thought, I'll do it this way. Okay, so what you do, you know what, I'll do one of them and then I'll pause it. I mean, in case you forgot how to do it. I'm assuming that you're pausing this video as we go along. You're just going to try these on your own. So I'll do this one. So mass, I'll just write this. I think this is what I did in the past. I wrote down percent barium. And what I'm going to take is the atomic mass of barium times how many there are, and there's just 1. And then divide that by the entire molar mass and multiply by 100 to make percent. So barium is 137.33 grams divided by 261.35 grams. I'm going to write 100 here. You don't have to, but just make sure your answer is in percent. So then you would take 137.33 divided by 261.35. And I get 52.55%. So pause it here if you, now that you know how to do it, if you want to do it for nitrogen and oxygen on your own. But I am going to continue. All right, so percent nitrogen, and then I'll have percent oxygen here. All right, so 2 times 14.01 divided by 261.35 times 100. So here we go. So 2 times 14.01 divided by 261.35. I get 10.72%. And then oxygen, 6 times 16 divided by 261.35 times 100. So let's see, 6 times 16 divided by 261.35. 36.37%. Now some of you are thinking, Mr. Kors, oh, this is right. 7.3, I'm sorry. Now this seems right. Some of you are saying, Mr. Kors, can't I just subtract here for the last one? Yeah, you can, but if you've made a mistake there, your mistake's going to continue. So don't be a jerk, show your work. I don't think I've said that yet today. Anyhow, show your work for each one when you do these. Okay, on to the stoichiometry experience. Remember, stoichiometry combines the excitement of equations with the fun of moles. So I don't know if you're wondering why I only wrote half the equation there. That's because I want you to complete and balance it for review, depending upon what you're doing, how you're doing this. So I will balance this for you, and then we'll start the problem. Fe has a charge of +3, Cl is -1, Ba is +2, SO4 is -2. I did this on purpose because I'm going to have Fe. Oh, by the way, I knew it was a charge of +3 because of this 3 right here. All right, if you were to mark it +2, I would mark it wrong. So Fe is +3. SO4, check your chart, you'll see it's SO4, not SO. SO4 has a charge of -2. Plus Ba with a charge of +2. I don't write down Cl3 because on my chart it's just Cl, so I write down Cl with a charge of -1. There, I've predicted the products. I've done the first step. Now I'm going to, write correct formulas, and then I'm going to balance the equation. All right, so here we go. 2, 3. Yeah, that's a mess, and I did that on purpose so we can practice finding the molar mass. And then let's see. Don't write down the 1, I write down a 2 there. Okay, let me wipe out these charges so we're not confused. All right, now I get to balance the equation, which I forgot to do earlier. How embarrassing. 1 Fe, 2 Fe, so I'll put a 2 there. Oh my gosh, I got 2 times 3, I've got 6 Cls. No prob, Bob, I'll put a 3 here. 3 times 2 is 6. 3 Ba, 3 Ba, 3 SO4, 3 SO4, all good. All right, so the first question I have there, given 25 grams of FeCl3, how much Fe2SO43 should you get? So I have to find the molar mass for FeCl3, and I have to find the molar mass for Fe2SO4 in parentheses 3. Okay, Fe 55.85 plus 3 times 35.45 for Cl. I'll punch that out later. 2 times 55.85 plus 3 times 32.07 plus 12, because 3 times 4 is 12, plus 12 times 16 for oxygen. So I'm going to punch those out. So I got 55.85 plus 3 times 35.45, 162.2. All right, then here I've got 2 times 55.85 plus 3 times 32.07 plus 12 times 16. 399.91. I'm going to double check that one. 2 times 55.85 plus 3 times 32.07 plus 12 times 16. Yep, I was right. 399.91. Or I could be wrong twice. You never know. All right, so it's 25 grams of FeCl3. So 25 grams over 1. All right, then I'm going to write down 1 mole FeCl3. Underneath that, I'm going to write down 162.20 grams. Okay, now there's 3 steps to this. I just did the first step. The first step is to convert the given mass to moles, which I did. Then I'm going to apply the mole ratio. You can only see part of me here. And third, I'm going to convert the moles to mass. All right, so next step, mole. Mole FeCl3. What number do I write in front there? I check my equation. There's a 2 here, so I write a 2 there. So moles of FeCl3 cancel. All right, now what do I need for the next one? Okay, I want to know how much Fe2SO43 I get. Hey, there's no number there, so it's understood to be a 1. So 1 mole Fe2SO4 in parentheses 3. All right. I want that to cancel, so I'm going to write down 1 mole Fe2SO4 in parentheses 3, and I'll write down 399.91 grams on the top. So then I'm going to punch this out. All right, so 25 times 399.91 divided by 162.2 and then divide it again by 2. So I get 30.82 grams. All right, so 25, I'll do that again, 25 times 399.91 divided by 162.2 divided again by 2. Yes, I'm correct. Okay, on to the last one. Given the amount of FeCl3, how much BaCl2 should you get? Okay, so now what I have to do is I have to find the molar mass for BaCl2. All right, so what I'm going to do is take my calculator, add that up. So 137.33 plus 2 times 35.45. And I get 208.23 grams. All right, now let's see. Same amount of FeCl3, that was 25. So I'll have 25 grams over 1. 25 grams of FeCl3, so I'm going to write down 1 mole FeCl3. Underneath that, I'll write down 162.20 grams. Now I do the mole ratio step. Mole FeCl3, what number goes in front? A 2. That cancels out. The stuff I want is BaCl2, so I'm going to put 3 mole BaCl2 on the top. So 1 mole BaCl2, and then 208.23 grams there. Oh, I'm sorry. So 25 times 3 times 208.23, 162.2, and then divide it again by 2. And I get 48.14 grams. All right. Now, I just realized as I went through this that I think it was last year's class. We did this at the start of the second semester, but I included it as like the first semester review because if you remember, our next topic was electrons, and that's something that's completely different. So what you need to do is I have attached a review sheet. You're going to need to complete that. That will be the assignment for, if we get this right, this will be Tuesday. And then why don't I have, let's see how you do on that, and why don't I have the test available for Thursday of next week, and you can do that Thursday and Friday. So next week, Tuesday, you'll have the review. And then you'll have the test for that Thursday and Friday, and then I'll start reviewing the second semester the following week. I think it'll be a Tuesday because we're going to have Labor Day. We're doing this attendance thing, so I'm going to have an attendance assignment for each one, so you have to check in each day. I'm recording this on this really hot day. You know, sorry, I'm going to take out my phone here. Excuse me. I want to see what the temperature is. Not in this room, it's warmer. But what the temperature is outside. All right, I'm going to say we're in Milwaukee. Or should I say we're in Tulsa? Let's say Milwaukee. All right, 91. Holy cow, 91. Well, what is that in Celsius? I'll be back. Well, according to my phone, it's about 33 degrees Celsius here in Milwaukee. So that means, geez, we're pushing 300K here. 296K, that's pretty darn warm. All right, yeah, just think, the winters will be in the 260s, and we'll say, what the heck? All right, we'll say how cold it is. All right, so anyway, yeah, I already told you what we're going to be doing for next week, so I guess I'll just say have a good weekend. Bye.